Okay, today we're going to focus on subtracting polynomials. The only difference between adding polynomials and subtracting polynomials is the minus sign or subtraction sign in between the two polynomials. If you notice, we have two sets of parentheses here, and that's going to be the main thing, the main difference between adding and subtracting. We talked about with adding polynomials, the parentheses really didn't matter because we were just combining like terms. However, with subtracting, this subtraction sign in the middle is the biggest issue going forward. A lot of kids make a mistake and they only associate the minus sign with the first term inside the second set of parentheses. So if we were to have, let's say, negative x, a term like this, the coefficient of this x term is really -1. Okay, there's a 1 in front of everything, every term if nothing is written. So there's really a -1 in front of this parenthesis. So we would use the distributive property to distribute that -1 to all terms inside the parenthesis. So we have -1 times 3n squared is -3n squared. -1 times positive 11n to the fourth is -11n to the fourth, and then -1 times -7 is +7. If you notice, I did drop the parentheses here, and I didn't do anything with this first term, this first polynomial, so all I'm going to do is I'm going to bring it down without the parentheses. Okay? My next step after I distribute is to combine like terms. I'm going to go ahead and put this in standard form as I go. So we will take my highest exponent first, which is n to the fourth. So I have -3n to the fourth and -11n to the fourth. Remember, when I combine those, I'm combining, adding, or subtracting their coefficients. So we have -3 and -11 gives me -14n to the fourth. Going in decreasing or descending order, I'm looking for my next highest exponent, which is n squared. I have +10n squared, and I have -3n squared. When I combine those, the coefficients here, 10 minus 3 is 7n squared. I have an n. If you scan your remaining terms, I don't have any other n's, so that's going to be +8n, and then my last term is my constant, +7, giving me a final answer of -14n squared plus 7n squared plus 8n plus 7. Our second example today is an old Regents question. They give us a equals 3x squared plus 5x minus 6, b equals -2x squared minus 6x plus 7. And they want us to figure out what a minus b is. Okay, so here what I'm going to do is I'm going to substitute. If you notice on the previous example, I did have a set of parentheses. So a is going to go right here, and that's this polynomial here, 3x squared plus 5x minus 6 minus, and b is going to go in that parenthesis, -2x squared minus 6x plus 7. I'm going to follow the same steps I did in the previous example. There's really a -1 here, and I'm going to distribute that -1 to all terms inside the parentheses. So -1 times -2x squared is +2x squared. Remember, we're dropping the parentheses when we do this. -1 times -6x is +6x, and -1 times 7 is -7. If you recall, I didn't do anything to the first polynomial, so that comes down untouched. After I distribute the negative sign, now I'm going to combine like terms. Again, look to put it in standard form to make it easier for you as you go. So I have +3x squared. If I scan my other terms, +2x squared. Again, like terms, same variable, same exponent. 3x squared and 2x squared gives us 5x squared. To continue, now I'm looking in descending order, so I have 5x, scan my other terms, and 6x, +5x, +6x. When I combine those, I get +11x. And my constants, -6, -7, gives me -13. giving my final answer 5x squared plus 11x minus 13. Again, the biggest thing here, the biggest step to remember is to distribute that negative sign. Okay, in both examples, that was the only difference between addition and subtraction.